Hi, this video is a part of Deep Learning with TensorFlow playlist. In this playlist, I quickly explain the logic and implementation of deep learning algorithms and applications using TensorFlow. Note that I do not code along, rather I make use of pen for explaining the tricky parts of code so that you people can read the notebooks and re-implement these algorithms from scratch yourself. Code files for each of the video will be given in the description. So I'm expecting my audience to have a good understanding of deep learning in general, and they just need little hints for implementation of these algorithms from scratch using TensorFlow. In this video, I'll talk about multiple networks utilizing multiple sources of data for prediction. Consider we have to predict the price of house. Now, suppose we have the picture of house and also we have different tabular data set containing different attributes such as number of bedrooms, number of bathrooms, and total area, etc. What we can do is we can use simple feed-forward network for these tabular attributes and then CNN for pictures and combine both of these networks for final prediction. Let's jump to the whiteboard and notebook to understand the idea and code it in Python. Okay, so we have to deal with multiple types of data set. For that reason, we are saying that these are the networks which can incorporate multiple sources of data. Basically, what we are doing here is we are giving an example where we have to predict the house price, and we have different tabular attributes such as number of bedrooms and bathrooms and total area and some other attributes. And we have also this image of data set, and we could also have what we call the description of the house. Once we have this description or the comments of are somehow in a language form, we have description or whatever, or comments, or there could be anything, but in language form. This is the important part. So we have totally three different types of data set. One is completely tabular and structured. This is a structured, and both of these are unstructured. And within unstructured, these are images, and these are what we call a language. So language is also a sequential data set. So this is like kind of a sequential data set where each of the word is dependent upon the previous word. So this sequential kind of data set is well dealt using recurrent neural networks, or LSTMs, or GRUs. So these all are variants of this special structure of recurrence within neural network. And this images also have this property of a single pixel being dependent upon the surrounding pixels. So that's why we apply these convolutions and filters filters within a convolution, and then we also do pooling in convolutional neural network. So we apply convolutional neural networks usually for images, and LSTMs and RNNs for the sequential data like language, and we use simple neural network for what we call these house attributes, where we are just having these input layers, these hidden layers. These are hidden layers, and we have output, and they all are densely connected. For that reason, these layers are called dense layers. Okay, now as I have already explained, and I'm expecting that you know all of these details, so then what we do is we create these separate networks for each of, suppose we have this network for tabular data, and this convolutional neural network for these images, and we have another network RNN for these language description. Then we combine all of them. If we have two, we combine two. If we have three, we combine three. Once we combine all of them, then we concatenate them. Then we apply a single layer. Some people might use multiple layers, but usually a single layer neural network, and then we predict the data set, and then we back propagate the error. And back propagation is done itself within the TensorFlow using automatic differentiation. We don't need to understand this mathematics, but it's good to know for intuition purpose and for tuning purpose. Okay, so the error, when it reaches to this point, it will distribute towards each of the side. Depending on each of the side's contribution. Okay, this is how it works. So we have to just define this architecture in a form that it makes sense. So the main task in TensorFlow is basically defining the architecture. Once we can define the architecture which can accept these multiple inputs, and at the end they can grow their own network, and at the end they concatenate all of the networks, and after that they use this error and backpropagation for updating the weights for each of the individual network layers. Okay, this is how it looks. So first of all, because finding these images are difficult, so that's why these CNNs are usually deep. So this part is basically all for CNN. So this is like CNN from start to here, and this is a very simple neural network. Okay, then they both are concatenated here, and this is here we predict the final output. Look at the CNN, and the CNN is really big if you look at it. Okay, now we have understood this whole idea of using these multiple inputs, growing their own networks. So just let me show you like it is representing the own network for a whole image data set, and this is a separate network for this tabular data set, then we concatenate both of them and we find error because we have to predict the same value using both of the data set, and both of the data set are representing the same is having the same kind of information to predict the value of price, whether it be image, a description, or a tabular data set. So why not to find out the error, a common error, and then back propagate this common error into all of the networks. This is what we mean by using multiple sources of data for prediction using multiple networks. Let's code this idea into Python. Before coding in Python, I just want to tell you a little detail about TensorFlow because that will be helpful. Okay, in TensorFlow, we have two different APIs where TensorFlow in TensorFlow Keras, we have this sequential API and we have this what we call functional API. So in sequential API, now whenever we have this conv layer and this pooling layer and this conv layer and pooling layer, suppose, and this dense layer, so whatever the output of this conv layer is, this pooling layer is expecting and pooling layer is inferring and is using the output of previous conv layer as an input, and the output of this pooling layer will be used as an input for the next conv layer, and this output of this second conv layer will be used as an input for the next pooling layer, and the output of this pooling layer will be used as an input for the dense layer. So this is how it works. However, if we have to encode the same thing into a functional API, then what we will do is consider we have this input layer in the first. So then what we will do is we will say that store the output of this conv layer, which is taking input as an input, and then again store the output of this pooling layer, which is taking the input with the input as the output of previous conv layer, which is stored in this out. So we will use this out. Okay, now this out now contains the output of this pooling layer, not the output of this convolutional layer. So again, what we will do is we will store this output using this conv layer, and this conv layer, second conv layer, is taking the input of previous pooling layer. So this is how it works. So pooling out and again out, and this is dense and out. So these both of the implementations are right, but this functional API gives us more control. So if you are dealing with very simple networks, so we can go away with this sequential API, but for complicated functions and for complicated networks, this functional API gives us much more control. Okay, then let's go to the let's jump to this coding part where we are just importing these libraries. After importing the libraries, we load this dataset, house dataset, and this is tabular data containing all of these information of bedroom, bathroom, area, zip code, price. Okay, once we have this data frame, then we load house images. We have different house images which we resize, and the size is actually 32,32. And then what we do is this is one of the image that we are showing you. So these are 4 different images concatenated together from different angles. Once we have done that, then we split the data set. After splitting, we are actually normalizing the price, and then we look at the continuous data set and we min max scale it, so to have this value between 0 to 1. Once we do that, then we one hot encode this categorical data, this zip code data, and then we just stack these both categorical and continuous data set to come up with this training attribute. So this is kind of pre-processing part. Once we have done that, then we create this multi-layer perceptron for our tabular data where we are using the sequential API. We add this dense layer having 8 neurons, then another dense layer having 4 neurons. Then if we are doing this regression task, and in this house prediction is basically a regression task. So what we do is we use the activation of a linear activation having a single neuron. Then we create convolutional neural networks given this input shape and this channel dimension information. Channel dimension is actually -1. Why is it -1? Because the depth information is stored in the last dimension, so that's why we are using -1. And depth information contains, basically, if we are having three depth dimensions, it means it's a colorful picture having 3 different dimensions of RGB, red, green, blue, and each intensity of red, green, blue, the combination of this red, green, blue is what we see through our naked eye in the pictures. Okay, once we have done that, then we define the model input having this input shape. Then what we are doing is that for each of the filter that we have given as an input parameter, then if it is the first iteration, then we are saying that X should be input and conv2d will be taking input. This is a use of functional API. Okay, so this F will be the filter that we'll be using for the first time, and then we'll apply ReLU activation, then batch normalization, and then max pooling. This is how it is done for 3 different filters that we have just given as an input parameter. We could also change all of this. This is a specific kind of architecture that we are using. Then we flatten this data set and we apply this dense layer of 16 neurons. Then we apply the ReLU activation, again batch normalization, and dropout of 0.5. Each of this X is representing the input that we are giving to this specific layer, and that input is actually in output of the previous layer. Okay, once we have done that, then finally what we do is we apply this final dense layer of four neurons, and then we apply this ReLU activation function. And again, we are looking at a regression task, and this house prediction is a regression task, so we apply this linear activation function, and this is how we construct the convolutional neural network. Now this is where we have called these functions, and we have called this multi-layer perceptron and CNN. Then what we do is we concatenate both of these outputs. The output of CNN and multi-layer perceptron is concatenated together. This is what we call combined input. Then using this combined input, what we do is we again apply this dense layer of 4 neurons and final dense layer of single neuron having linear activation function. This is where our model input is basically defined in the form of list, because we are having 2 different inputs. One is image, which is in this CNN.input, and another one is tabular data, which is in this MLP.input, and we have this output stored in this X. Once we have created this graph, this is where we are creating this graph. So we have just created the graph. Now all of the thing is really easy. We have to just compile by giving the relevant information of optimization, which we are using here as in Adam, this learning rate, this decay, this loss function, this optimizer. Once everything is defined, then what we simply do is we fit this model, and all of this automatic differentiation and this adjustment of weights will be done automatically. And this is where magic happens behind the scenes in the TensorFlow. Now we predict the data set, and after prediction we flatten it and we look at the difference, and this is absolute percentage difference. This is what we look at, the mean absolute percentage difference and standard deviation absolute percentage difference. Now this is where we have looked. This is what we have looked in our notebook, in our on our whiteboard, the architecture, and this is the architecture that we have actually developed. This is the visual representation of the architecture. I think so this whole thing will make sense in a much better way if you understand this functional API and the sequential API. Once you understand that, then we are just using the parameters of each of the layer, whether it be convolution or dense, and then we are just applying it. I hope so this makes sense now.